All right, here we go again. The question today is, how do you design the vending machine in Java? I'm actually not sure if this is a system design really. I mean, it's more like an object oriented. I mean, I guess it's let's take it at face value. Let's say this is truly a system design question. Um, so first let's discuss what I so first let's talk about the requirements, right? Let's say that's all they give me. What is the vending? How do you design a vending machine? So what are its primary functionalities? Its features. So let's go over that first. First of all, we have that it needs to be able to accept money. So I should probably write these down. You know what? I'm gonna do it digitally this time because I don't really have paper and a flat surface to try it on. Okay, so vending machine. Accept money. Requirements. Make this a bulleted list. Dispense product. Make selection. So it really helps me to think of what, actually go through what the end-to-end user steps for a few cases, if that exists. So that's what I'm doing here. So first thing you usually do is you kind of walk up, you put your money in. You make a selection like D3. So make selection. They need to dispense a product, and potentially, if it takes multiple bills, dispense change. Or even just, if it costs 75 cents and you put in $1. And already right off the bat, I can think of a lot of clarifying questions for something as open-ended as this. When I say accept money, does it accept coins or bills? So I'm adding these into my bullet point list. Coins or bills? Digital payments? A lot of them I've seen nowadays accept what is it, like contactless, Apple Wallet Pay, or the RFID kind of like tap your card to pay. What kind of and assuming it does take coins or bills, there's more if we're really designing this, we need to design it, dive in more. So which coins? Most don't take pennies, right? And which bills? Most don't take more than, even $1, but some take like 5s or 10s. But I don't know of any that would take 100. And if maybe the interviewer said, well, what if we said it took like a 20, or like the product manager asked it takes a 20? I'd say, well, that most machines I'm aware of return change, like coins. So unless maybe you had dollar bills, I haven't really seen any of those, or dollar coins, I suppose. It's very difficult to dispense in larger bills, like provide change for larger bills. So that was kind of some of the things on accepting money. Is there anything else? So I'm only thinking of it from an end user, but there's also like the supplier part. They need to be able to insert change. Insert change. I'm gonna assume they're only change in bills. It can only return change in coins. I can tell I'm speaking a little fast and rushed. I'm gonna slow it down a little bit. So we're still on accept money. I say from the supplier side, and you need to be able to insert change, withdraw the money that isn't it, and perhaps you need some way of telling the provider, whoever is like restocking this or managing this vending machine, that you're don't have any change left. Or providing that message to the user, just saying, hey, error, needs servicing. So let's say that's, I guess, two things. One is error to user if change unavailable. Notification to supplier that change is empty, or just any sort of money related change. It's, let's say it holds bills, and however it holds bills is getting full. Now, making a selection. So I think this is something I need more requirements on. How many choices are there? If there's only 5 choices, then we only need like a very simple number pad. But if there's 30 choices in this vending machine, or 50 choices, I mean, I guess you can still go with like 1 1 1, or you can still do a simple number pad, but I think most do like an A3 probably, and that makes it easier for the end user, right? Because they can see like row 1, or row A, row B, row C. I don't know how they're usually organized, but that helps the user experience. They can know the third item down, fifth to the right is C5. So making a selection, under my bullet point here, I'm going to say what are the specs, how much variety. And making the selection implies, of course, the within the vending machine, like being able to store all these. So like they need to be able to replenish. Storage/replenishment. And what I'm listing here is just all the things that a vending machine needs to do, right? So storage/replenishment of stock. Interesting thing is, like, maybe it should be aware if it's out of stock or not. I think, by the way, a lot of these requirements I've just been mentioning are potentially extraneous, right? I'm spitballing because there is a limited requirement, and I have no one to answer my questions. I have no one to ask these clarifying questions to. But what I would ask is, does the vending machine need to know when an item is out of stock? If so, you need to be able to also set that, I put 10 bags of Lay's chips here. So need to know amount of stock. But sometimes, like, some of the vending machines you can't see inside, but some are perfectly clear. And potentially you could just say, well, it's the user error if they enter a number that is clearly like an empty selection, and just all the chips have already been purchased. Anything else for making a selection? Yeah, like so sometimes someone chooses a selection that's unavailable, like off the board, right? So some validation of input. Maybe like on your keypad you have H, but there isn't actually a row or column H. I said make selection and actually dispense the product. Depends on how simple of a machine we're going for here, but let's say, like, what will we actually need to do? What are some potential things we would need to do when we dispense a product? As mentioned, okay, so I think I combined some of it earlier, but like, check amount of stock, if that feature is available. And I'm actually, I should have asked this from the very beginning. What kind of vending machine? What kind of things were we going to storing? Because they affect the design. Like, shoot, where was I going? Like, how simple is it? Like, how simple is the actual dispensing? It's something I like to clarify, because some drink dispensers, they actually move an arm and actually navigate over to the row, and then your Pepsi moves to the arm and then like eventually gets lowered. Uh, I'm assuming they do this so that it doesn't shake up your drink too much. But if it's a, and so maybe like, you'll need some software to actually design moving the arm, moving it up to the right. But maybe you're just the really typical chip dispensers where it just does a rotation of a spiral and pushes one out. So like, I'm just gonna say any special requirements on dispensing. Gonna clarify that with like example spiral dispenser versus drink arm dispenser. I mean, for all we know, this could be one of those crazy like ice cream or like cheeseburger vending machines that like actually assemble everything. So yeah, I should have clarified instead of jumping to conclusions, saying this is the type of vending that it is the typical vending machine. And then the next thing I had was dispensing change. So obviously we'll need some software. I'm going to say need some software for determining how much change to return. Similar to others, maybe we need some monitoring or alarming around available change. In terms of, I mean, if we're, I don't know how low of a level like implementation we're trying to get here, but I was just gonna say that like a greedy algorithm to say quarters first, use as many quarters as you can, then use dimes, then use nickels, probably makes the most sense. I guess dimes are actually interesting because you can probably store more dimes than you can quarters, by volume, and they give you more granularity. But also, this is probably unnecessary to the end user. It just adds. Ideally, we can limit the price. And this is a clarifying question. Can we say we limit the price of products in here to increments of 25 cents? Because if so, it definitely solves a lot of problems and allows us to optimize. We're able to own, like, the guy or girl who operates and resupplies and owns this vending machine can only needs to buy only needs to exchange and pack resupply it with quarters. Less things that can go wrong then, right? And in terms of like physical attributes, I mean, it's going to need some sort of like catcher or something to hold the coins. That's in terms of like use cases. That's what I'm starting out with. I'm gonna assume that there's also just an object-oriented design part of this. So I'm gonna say OOP in my notes and just say, how would you design it in terms of object-oriented programming? So I'm gonna kind of go through my own use cases again, and this time just with a different lens. So, and just kind of point out all the things that I think should be modeled as objects, and any areas I can see inheritance or something making sense. So, accepting money, coins or bills. So I can see a parent class. What do we call it? Money? No, I want to come up with a better term than that. Currency. And to that's an interface. And to abstract classes of coin and bill. Now, why am I going abstract? Because the actual representation of the coin, like, or the representation of the bill, the actual implemented class would be like a $1 bill or a $5 bill. And this is where I would also go back to requirements. Is it necessary? Like, assuming time is limited, not everything is always like perfectly technically designed. If we're limiting just to, first of all, if we're limiting just to $1, then we can just go straight to the implementation class, right? There is a dollar class called dollar. In fact, we don't even need that because, in the code, there's only one number it could be. But I would still keep at the minimum that level of object design, right? So there's a bill, dollar. And let's say it's a little more complex where we have like $5 as well. We just take those $2 bills. Coins, let's stick to 25 cents. And yeah, coin, there's only one implementation of this abstract class, but I think that's perfectly fine. I don't imagine for our use case that things will get too complex, where we really need that inheritance of like currency, and then to like be like, oh, if instance of currency, then coin.get value. I don't really think we'll need that for a vending machine. At least the one we have designed so far, but this is the proper way to design it if it was like very advanced. Could take tons of different kinds of dollar bills, tons of different kinds of coins. This is more of like a coin star. Then this design would make more sense. So coins and bills, digital payments. So I'm gonna label some of these just as like future improvements, and we can talk about it more. We can expand on it if time allows, right? But I want to make sure we get like the basic happy path use cases first. So I'm not gonna say digital payments. Inserting change. So I don't know if, so there's the concept of money. I feel like we could make like an object of type like transaction. So once a customer enters, puts in a 25-cent coin or a dollar bill, we create an instance of a transaction. And as they continue to add dollar bills, maybe an item is $3, we can keep on adding we can keep on adding instances of a bill to this transaction. So you have like 3 $1 bills and maybe a coin as well for 25 cents, right? And it'll store these. I guess we don't really need the class. So there's if we get into the nitty gritty, there's some probably like translation layer where the vending machine will identify this as a $1 bill and then convert it to the $1 class and pass it in. But in terms of the transaction, just keeping track of how much money was spent or was inserted, it can probably just do like the bill.getValue, which is like $1, and locally just sum it up. And like transaction dot inserted money variable equals $3.50. Like methods on this transaction class would be like dot add currency. You would pass in a class of currency, an instance of currency, and then in there you could just add into a local variable, a private variable to this transaction to say this is the value. I didn't write any of that down at all. So let's say class transaction methods like, method, not even like, let's say methods add currency. I can think of some things that I'll need to do later, such as get change. I can see this being in a util class. For now, I'm going to leave it in here because maybe we want each transaction to know what the change is after a selection is made. And so on that note, selection is another. And maybe we want to store like A3 or something as a string. Maybe the supplier wants a log of the hottest items. And I mean, they could probably do that with the supply, but maybe it would be very convenient for the vending machine to tell it which ones are their hot sellers. I'm kind of assuming we will store these transactions, but like on the device, or send them, call some API, and it's got like the vending machines hook up to the internet or something. Otherwise, we could always just destroy the transaction after. So I'm gonna, for each, what I'm doing is listing out the methods, or what I was doing was listing out the methods, but I'm gonna say actually just like get set currency. Oh no, that doesn't make sense because I'm not really setting. It is add currency. But for the selection, there's like get set selection. And then I talked about kind of physical attributes of the vending machine that aren't as important right now, such as being able to remove the money that's inside of it. And like being able to notify to the supplier that the change is empty or bill holder is full. This is definitely separate from the transaction. Right now, at least, I'm thinking of these less as object-oriented design, so much as like external API calls, calling some service to notify, like some pager, to say, hey, we're out of stock. Right? And this will be done. This can probably be done at the end of every transaction. Let's just take a note of that. That's just a good case to discuss, right? At the end of every transaction, check if there are any I don't know what to call them, constraints, such as change in stock, bill holder full, warnings to notify, etc. So when making a selection, when the user actually enters a selection, one of the things we want to do is validate the input. I think that's the most, out of the things I mentioned earlier, that's the one that's really like software dependent. And something as static as a vending machine, I mean, this could really just be a static list, a static array or array list of just valid combinations. Right, so like, A1 through 5, B1 through 5, C1 through 3. And it could just check if the selection is in this list. That's just the most straightforward way to do it. I'm going to say that. So making selection, validation, Input validation will probably can reference a static list of options of valid inputs. One thing I didn't mention earlier is validation that we have that the user has entered the amount of money. Another opportunity to kind of use object-oriented programming is we can, if we were kind of over designing, we can have a interface of vending spot, right? And this is a very scientific name, I know, but it holds, this is like the A1, A2, each one is a vending spot. And its attributes here are price. So, A4 is always going to be, or not always, but I guess this should be settable, but it's like 75 cents, and A5 is $1, right? So price is local to each vending spot. And selection, I'm going to call it identifier, spot identifier. And even though earlier I said it's in a static list, actually I do still think about the static list is the quickest way to look it up. Obviously on a vending machine, we have just one user using it at a time. So it's not a big deal to iterate over a very finite limited list of vending spot classes and say, oh yeah, is this spot one of them? But in terms of just having good design, then I think we can still have a list that validates, and then it goes to the actual object, searches for the object. So like the hash table would be like the spot A1, and then that would be the key, and then the actual value would be a vending spot, which represents A1, and it would have the price and the spot identifier within the object as well. Right. So after they make the selection, you say, okay, the selection, yes, this is A1 is a real combination. You would also check between the vending spot and the the transaction object. Oh, has the user put in enough money to purchase this item? Is it greater than price? Is what is it? Current value. Current value, like greater than vending spot dot price. So then let's assume. Well, let's actually assume that it isn't the case. We'll want to throw some exceptions. I don't want to just go through the happy cases, right? We'll throw an exception, which will probably be caught further up the call chain. And it'll display like error, insufficient funds on the actual like little LED display. So going back to the happy case though, let's say there is enough funds, it's equal to or greater than the amount in this transaction is greater than or equal to the price of the vending spot. We call some method. We call some method to actually dispense the item, and then we would call what I like is actually being able to log each transaction, so that's why I have the transaction object. So I would set In fact, in there, instead of, I know I had like a selection, and I think I said it was a string, but let's say it was the vending spot, which starts as null, but once a selection is made and validated, the vending spot gets set. Then we would call get change on it to know what the difference we need to dispense is. And get change, just so we don't to enforce good programming standards, we're not going to assume what the state is. We can have a variable that like enumerates the state of the transaction, but in this case, I'm just going to say if vending the spot is null, that means like an item hasn't been associated with this transaction yet. Thus, get change should throw an exception and say, hey, no selection has been made yet. And this isn't to the end user. This is more like internal to the programming, right? Anyway, so then you would call get change, and it would say, hey, the difference is 25 cents. And here I think this is where that utility class I mentioned earlier comes in, where I'd call the utility class and say, hey, I need 75 cents. Oh, well, I did say this is just going to be quarters. So this is actually, that definitely simplifies our problem, and I think makes sense for the end user. We don't need the utility class at all. This is one of those things we can hard code and say 75 cents divided by 0.25, dispense 3 of 3 coins. And since we only have 1 coin, easy peasy. I didn't write a lot of that down since dispensing change, but that's fine. That's fine. We're talking it through. So I think that covers like a really basic operation, and we covered a few error states, like bad inputs, not enough money. If you try to call like get change before you actually have chosen an item. Some of those are end user facing, some of those are more internal. See, I'm just checking the time here. We're actually already at 32 minutes. I think there's definitely a lot of things we could expand on, right? This is a cool problem because of that. We can say, well, let's say we do want to support multiple coins. Excuse me. Then how would you change the object-oriented structure? In that case, that's pretty easy. We'd add a new type of coin. Let's say it's just a dime. We go down, a dime. And of course, when we dispense change, we're going to need to change that a little bit to say, oh yeah, dispense as many quarters as you can at first. And this is probably where that utility class would come in. And then dispense dimes. I guess a problem is here that we can't use the greedy algorithm anymore because you may run out of coins. I'm sorry, wait. What I mean is you cannot just keep adding quarters. Let's say it's 80 cents, right? You cannot just add 3 quarters and be like, all right, now add a dime. Obviously that doesn't work. So what I guess I would do there, I want to like properly take this as like a programming problem, even if it is pretty simple, and not like rush it. But we could, at its simplest, start from the smallest coin value, in this case, which is dime. Well, so check first. Is the amount of change I need to give divisible by my largest coin? Right, and if not, then give as many as I can. So that would be 2 coins, 50. Not give as many as I can. I'm sorry. Yeah, we would need to give the dimes first. We would. If it was 80 cents, I'm going to stick with that example. We need to continue dispensing dimes until we have a number that is fully divisible by the larger increment, the 25 cents. So that would work. And I'm just kind of going back to this prompt. I actually did not try to read anything because I didn't want to like give myself too much hints. But make sure you insert a coin, get a product back, and get your change back. Also write the unit test to demonstrate that these common use cases work. If you get stuck, you can read my 2-part articles. Okay. Use cases. Test cases is a fun topic. I'm not actually going to go through them right now, but for this, but I will just kind of list some things off the top of my head. I know we already talked about some. I'm going to not cover those. But let's say you just try to type a number, like you try to, you don't put in enough money, right, for the selection you've made. Or what happens when you haven't put in any money at all and you start hitting numbers on the keypad. This is why you got to write down your use cases. You got to walk through them. What happened? Well, like even though we said it takes ones and fives, how many ones and fives can a user put in? $300? No, there's more validations we can do there. Making selections. We kind of talked about making valid selections and doing some validation there. Validation of how much money was put in. Dispensing the product. Don't think there was as much software stuff there. Dispensing change though, that is, yeah. So we kind of covered a little bit about like how to dispense change. If it's just quarters, it'll always be a whole number. That's just divisible by 0.25, but otherwise, we would definitely test that utility class a little bit more. Whole numbers that we know are divisible. Numbers that aren't, they should throw in an exception. So let's say for whatever reason there was an item set to 83 cents, but we only carried quarters and dimes. That should throw an error, right? There's no possible combination that would give you 83 cents of quarters and dimes. All like dime, like just one dime, just one quarter, all quarters, and quarters and dimes. Like what if change is greater than $1? I mean, in theory, how we've described this so far, it should still work. It should, if it's $2 and change, you should still just give 8 quarters, but still something I'd test. Maybe someone else is developing that other part of the code, and I don't want to assume that. I mean, maybe they think change is always coins. I don't want to make that assumption. Yeah, those are the areas I test first. And since we're at 39 minutes, I'm gonna call it completed.